Hello, listeners, hope you all are doing well. Today we will discuss an amazing topic about water on the moon. So, without wasting time, let's start learning. Scientists have gathered some of the most compelling evidence yet for the existence of water on the moon, and it may be relatively accessible. The discovery has implications for future missions to the moon and deeper space exploration. With no significant atmosphere insulating it from the sun's rays, it had been assumed that the moon's surface was dry. Until the 1990s, when orbiting spacecraft found indications of ice in large and inaccessible craters near the moon's poles. Then in 2009, imaging spectrometers onboard India's Chandrayaan-1 spacecraft recorded signatures consistent with water in light reflecting off the moon's surface. Even so, technical limitations meant it was impossible to know if this really was H2O, water, or hydroxyl molecules consisting of one oxygen atom and one hydrogen atom in minerals. Now, Casey Hannibal at NASA's Asa Goddard Space Flight Center in Maryland, U.S. and colleagues have detected a chemical signature that is unambiguously H2O by measuring the wavelengths of sunlight reflecting off the moon's surface. The data was gathered by the Stratospheric Observatory for Infrared Astronomy, SOFIA, a modified Boeing 747 carrying a 2.7 meters reflecting telescope. The water was discovered at high latitudes towards the moon's south pole, in abundances of about 100 to 400 parts per million H2O. That is quite a lot, said Mahesh Anand, professor of planetary science and exploration at the Open University in Milton, Keynes. It is about as much as is dissolved in the lava flowing out of the Earth's mid-ocean ridges, which could be harvested to make liquid water under the right temperature and pressure conditions. Now question arises, is this water useful in future? The existence of water has implications for future lunar missions, because it could be treated and used for drinking, separated into hydrogen and oxygen for use as a rocket propellant, and the oxygen could be used for breathing. Water is a very expensive commodity in space, said Anand. However, harvesting it from dark, steep-walled craters where the temperature rarely climbs above 230 C, which is where the bulk of any frozen water was assumed to lie, would be a perilous undertaking. If it turns out that there is a lot of water in these non-permanently shadowed areas, then that is potentially a very large area, and it is accessible because it is in sunlight, said Ian Crawford, professor of planetary science and astrobiology at Birkbeck, University of London. Questions remains. However, one is the form in which the water exists. One possibility is that it is dissolved within lunar glass, created when meteorites hit the moon's surface. Alternatively, tiny ice crystals could be distributed between grains of lunar soil. The latter would be far easier to extract, said Anand. So, how widespread is water on the moon? On the sunlit side, it is not yet known whether the water SOFIA found is easily accessible. On the other hand, the hidden, shadowy pockets on the lunar surface called cold traps are spread across a combined 40,000 square km. The other study has reported that is roughly the size of Kerala. The estimate used mathematical tools to analyze data from NASA's Lunar Reconnaissance Orbiter. The cold traps have gone without sunlight for potentially billions of years. If they do contain ice, it means water is going to be more accessible than previously assumed. Another is how deep this newly confirmed water source extends. If it were restricted to the uppermost few microns or millimeters, then its practical significance would be minimal. Although it would still be interesting scientific questions about how it got there, Professor Crawford said. The only real way to find out is to go to the moon and start drilling. This may not be far off. NASA's Artemis mission plans to send a male and female astronaut to the moon by 2024. British scientists are also developing a robotic drill to take samples of lunar soil from depths of up to a meter, as part of a Russian mission scheduled for 2025. But where should they dig? Permanently shadowed areas would still be the best bet, because water would be more protected from the sun's rays there. Another paper in Nature Astronomy suggests that these areas may be more numerous and accessible than previously assumed. Using images from the Lunar Reconnaissance Orbiter, Paul Hain, of the University of Colorado in Boulder, and colleagues mapped the distribution of smaller craters and areas of rough ground and calculated that approximately 40,000 square kilometers of the lunar surface has the capacity to trap water. although this still only represents 0.15% of the lunar surface. Their existence may also reduce the risk of conflict between moon-faring nations. With billions of potential water reservoirs scattered over the polar regions, the focus should be shifted away from the handful of well-known large craters and towards the multitude of potential landing sites our study reveals, Professor Haynes said. Earlier in October, 8 countries including the UK signed the Artemis Accords, a set of international agreements drawn up by the US, governing future exploration of the Moon and exploitation of its resources. The accords pull together the existing norms of behavior that we've established, such as recognition that exploration of the Moon should be for peaceful purposes, that there should be transparency in operations, and data sharing, and so on, said Christopher Newman, professor of space law and policy at Northumbria University, in Newcastle. Other signatories are expected, but Russia is hesitant. And China is prevented from signing because of ongoing trade disputes with the US. So, let's see what we will see in future. Have some fun. Okay. Viewers, thank you so much for watching this video. It's all about today. Hope you learn many things from this video. Before going anywhere, do click on subscription button and the notification bell for more informative videos. Thanks.